According to National Electrical Code Section 310.15b, conductors of different systems are permitted to be installed within the same raceway, provided that all conductors are properly identified. The key consideration is ensuring that the conductors are distinguishable and that the installation adheres to safety standards. The term raceway can broadly refer to any channel designed and used expressly for holding wires, cables, or busbars. This can include conduits, electrical metallic tubing, Y-ways, and other approved enclosures. A NEMA 7 junction box is designed for use in hazard locations where there is a risk of explosion. These enclosures are constructed to contain an internal explosion without causing a fire or explosion outside the enclosure. Combining different voltage systems, such as 460-volt alternating current and 24-volt direct current, in a NEMA 7 junction box is permissible under the NEC, but it requires careful attention to detail. Firstly, proper conductor identification is paramount. Each conductor must be clearly marked to indicate its voltage and function. Color coding, tagging, or other approved methods can be used to achieve this. The NEC provides guidelines for conductor identification in Article 310. Secondly, physical separation or barriers between the different voltage systems can enhance safety. This separation helps to prevent accidental contact between the high and low voltage circuits. Barriers can be made of insulating materials and should be securely fastened within the junction box. Thirdly, the junction box must be properly sized to accommodate all the conductors and any necessary splices or terminations. Overcrowding can lead to overheating and insulation damage. The NEC provides guidelines for box fill calculations in Article 314. Fourthly, all wiring and connections within the junction box must be performed according to NEC standards. This includes using approved connectors, properly torquing connections, and ensuring that all conductors are securely terminated. Fifthly, the equipment grounding conductor must be properly installed and connected to the junction box and all equipment served by the circuit. Grounding provides a path for fault current to flow back to the source, which helps to trip over current protective devices and prevent electrical shock. Sixthly, the installation must comply with the requirements for Class 1 Division 2 hazardous locations. This includes using approved wiring methods, sealing fittings, and explosion-proof equipment. Class 1 Division 2 locations are areas where flammable gases, vapors, or liquids may be present under abnormal conditions. The NEC provides detailed requirements for hazardous locations in Article 500 through 516. Now let's delve deeper into some of these aspects. Conductor identification is crucial for safety and troubleshooting. Color coding is a common method, with specific colors often associated with particular voltages and functions. For example, in a 480-volt alternating current system, black, red, and blue are typically used for the phase conductors, white for the neutral conductor, and green for the equipment grounding conductor. However, it's essential to verify the local codes and standards, as color coding requirements can vary. Tagging is another method for conductor identification. Tags can be attached to the conductors near their terminations, indicating the voltage, circuit number, or function. The tags should be durable and clearly marked. Physical separation can be achieved through various means. Insulating barriers can be installed within the junction box to separate the high and low voltage circuits. These barriers should be made of a non-conductive material and securely fastened to prevent movement. Another approach is to use separate compartments within the junction box for the different voltage systems. This provides a more complete separation and reduces the risk of accidental contact. Box fill calculations are essential to ensure that the junction box is not overcrowded. The NEC provides specific rules for calculating the maximum number of conductors, devices, and fittings that can be installed in a box. These rules take into account the size of the box, the size of the conductors, and the type of devices being installed. Overcrowding can lead to overheating, insulation damage, and potential fire hazards. Wiring and connections must be performed according to NEC standards. This includes using approved connectors, properly torquing connections, and ensuring that all conductors are securely terminated. Approved connectors are designed to provide a reliable and safe connection between conductors. They are typically listed by a recognized testing laboratory, such as Underwriters Laboratories, and are suitable for the specific type of conductor and application. Proper torquing of connections is essential to ensure a secure and reliable connection. Over-torquing can damage the connector or conductor, while under-torquing can lead to a loose connection and potential overheating. Torque specifications are typically provided by the connector manufacturer. Equipment grounding is a critical safety measure. The equipment grounding conductor provides a path for fault current to flow back to the source, which helps to trip over current protective devices and prevent electrical shock. The equipment grounding conductor must be properly sized and connected to the junction box and all equipment served by the circuits. Hazardous locations require special precautions to prevent explosions and fires. NEMA 7 enclosures are designed to contain an internal explosion without causing a fire or explosion outside the enclosure. These enclosures are constructed of heavy-duty materials and have tight-fitting covers. Other requirements for hazardous locations include using approved wiring methods, sealing fittings, and explosion-proof equipment. Sealing fittings are used to prevent flammable gases, vapors, or liquids from entering the enclosure. Explosion-proof equipment is designed to contain an internal explosion without causing a fire or explosion outside the equipment. In the specific scenario of combining 460-volt alternating current motors and 24-volt direct current level switches in a NEMA 7 junction box, several additional considerations apply. Firstly, the motors typically require larger conductors and higher ampacity than the level switches. The junction box must be sized accordingly to accommodate the larger conductors and the additional heat generated by the motors. Secondly, the level switches may be sensitive to electrical noise or interference. Shielded conductors or filters may be necessary to protect the level switches from noise generated by the motors. Thirdly, the control panel that the junction box connects to must be properly designed and installed to handle the different voltage systems. The control panel should have separate sections for the 460-volt alternating current and 24-volt direct current circuits, with appropriate barriers and labeling. In summary, it is permissible to run 460-volt alternating current and 24-volt direct current circuits in the same NEMA 7 junction box, provided that all conductors are properly identified, physical separation is provided, the junction box is properly sized, all wiring and connections are performed according to NEC standards, the equipment grounding conductor is properly installed, and the installation complies with the requirements for Class 1 Division 2 hazardous locations. Consulting with a qualified electrical engineer or inspector is recommended to ensure that the installation meets all applicable codes and standards. The importance of proper conductor identification cannot be overstated. It's the foundation for safe and efficient electrical work. Without clear and consistent identification, troubleshooting becomes a nightmare, and the risk of accidental contact with live circuits increases dramatically. Think of it like a well-organized toolbox. If all your tools are jumbled together, it takes forever to find what you need, and you're more likely to grab the wrong one. Similarly, properly identified conductors allow electricians to quickly and accurately identify circuits, reducing the risk of errors and saving time. Physical separation is another critical safety measure. It provides an additional layer of protection against accidental contact between different voltage systems. Imagine a crowded highway without lane dividers. The risk of collisions would be significantly higher. Similarly, physical separation within a junction box helps to prevent accidental contact between high and low voltage circuits. Proper box fill calculations are also essential. Overcrowding a junction box is like stuffing too many clothes into a suitcase. The zippers are strained, the clothes are wrinkled, and the suitcase is more likely to burst open. Similarly, overcrowding a junction box can lead to overheating, insulation damage, and potential fire hazards. The NEC provides specific rules for calculating box fill, taking into account the size of the box, the size of the conductors, and the number of devices being installed. Following these rules ensures that the junction box is not overcrowded and that the conductors have adequate space for heat dissipation. Wiring and connections must be performed with precision and care. Loose or improperly torqued connections can create resistance, leading to overheating and potential fire hazards. Using approved connectors ensures a secure and reliable connection. Think of it like building a house. If the foundation is weak or the framing is not properly aligned, the entire structure is compromised. Similarly, if the wiring and connections are not performed correctly, the entire electrical system is at risk. Equipment grounding is a fundamental safety requirement. It provides a path for fault current to flow back to the source, which helps to trip over current protective devices and prevent electrical shock. Without proper grounding, a fault can cause the metal parts of equipment to become energized, creating a potentially lethal shock hazard. Hazardous locations require special attention due to the presence of flammable gases, vapors, or liquids. NEMA 7 enclosures are designed to contain an internal explosion without causing a fire or explosion outside the enclosure. These enclosures are constructed of heavy-duty materials and have tight fitting covers. Other requirements for hazardous locations include using approved wiring methods, sealing fittings, and explosion-proof equipment. These measures help to prevent explosions and fires in areas where flammable substances are present. In the specific scenario of combining 460-volt alternating current motors and 24-volt direct current level switches, it's important to consider the different characteristics of these systems. The motors typically draw a significant amount of current, while the level switches draw very little. The junction box must be sized to accommodate the larger conductors required for the motors, as well as the additional heat generated by the motors. Additionally, the level switches may be sensitive to electrical noise or interference. Shielded conductors or filters may be necessary to protect the level switches from noise generated by the motors. The control panel that the junction box connects to must be properly designed and installed to handle the different voltage systems. The control panel should have separate sections for the 460-volt alternating current and 24-volt direct current circuits, with appropriate barriers and labeling. This helps to prevent accidental contact between the different voltage systems and ensures that the control panel is safe and reliable. Remember, electrical work can be dangerous, and it's always best to consult with a qualified professional if you have any questions or concerns. They can help you ensure that your electrical system is safe, compliant, and reliable. Always prioritize safety and follow all applicable codes and standards.